I'll tell you what, let's start with Neil and Rick. If you want to introduce yourselves, I think I would love for the students to see and hear a little bit about, how you got into this business, how you got into, working with Olson's particularly. You've both been there for a while and have some experience. Um, and then, even add in there, why is this a long-term career for both of you? Good morning, and thanks for being here too. I just want to say thanks so much to Olson Plumbing and Heating for doing this for our kids.
Well, you're welcome.
Neil, do you want to start?
I sure can. Neil Freeman is my name. I actually went to school for motorcycle mechanics. I graduated that, and I was in the cities at the time. Moved back here because I had a job lined up, and that kind of fell through. So I started down at Friendship Homes. I was down there for 11 years, and I was the foreman of the plumbing crew down there. And I didn't really like the way it was going at the time. And Rick had actually stopped by my house, my old house, to work on my furnace, and we got to talking and offered me a job. So I started here. Been here 8 years now. So last year I got my journeyman's license. I was supposed to take my master's test this month here, but that got canceled because of all this stuff going on. I just really like it because you kind of do something new every day. Get to go a lot of places, see a lot of things, and yeah, I guess I don't know what else to say.
Okay. It took me probably 3 months to convince Neil that he should come work for me. We met probably 3 or 4 times in the morning, just discussing the job. And I had great confidence in him because he had great mechanical ability. And we're very glad that he came on board. I started my plumbing career going to a tech school in Wadena. Went from there to T. Schaefer Plumbing in Stock Center for 3 years, and then had an interview to come back to Montevideo. And in the interview, I told the owner of Olson Plumbing at that time that I wanted a job that was going to make me the owner someday. And he hired me, and 35 years ago, and becoming an owner became a reality. So we're very happy to be part of the class today, and we're going to let Neil go ahead and show you some plumbing.
All right, you want to start now then, or?
Yep.
I guess the first thing we're going to do is show you how to solder some fittings together. Solder copper. One of the biggest things when you're soldering copper is you want to get it clean. It does not work so well if it's not clean. So I'm going to start by cleaning some of these. This is just rough grit sandpaper or emery's cloth that we use for this. Let's see if this will hold better. Maybe this is not going to work better.
Our makeshift vise is not cooperating.
It was solid. We don't normally do it this way on the job site. This is just trying to set up so you guys can see it. Stay. I gotta get my brush here.
Can you explain what you're doing there, Neil?
I'm just cleaning the inside of the fitting here. This is just a wire brush, so you want to clean both fittings when you do this. Some people think you can only get by with doing just the pipe. That is not a good idea, though. Do not recommend that. And this is flux we use. It actually cleans the pipe and helps get the solder in there so they solder together. I'm using a brush because this stuff is pretty acidic and it can actually harm your skin. So I suppose I could have had some of these planned ahead of time. I figured I'd show you how to do it though. Same thing, just cleaning the inside of it. Hopefully this all stays together, right? And this is the last one I'm going to be putting on here is an adapter to go to PEX. PEX is just a plastic tubing that we use a lot of times these days. It's faster and it's easier to do than copper. So that's what's kind of used in a lot of newer houses and or new construction. So, but we still use copper too. Try not to burn you. When you're heating this up, I kind of do some each on the fitting and on the pipe. Ultimately ending on the fitting because that's where it kind of draws the heat in and draw the solder in better. You can tell like that when he's just drawing it in good, you can see it go all the way around the fitting. If you were to have fitting or copper that wasn't clean, you'd be able to see spots where it didn't get drawn in well, or if there's water. I'm gonna do this last one here. So. Just like that, it's done. I'm going to try to cool that off a little bit so I can crimp onto it right away. When you're going from the PEX to plastic, obviously you can't have it too hot or it'll melt the PEX.
So that whole pipe is very hot. That's why Neil is making sure he's grabbing it with a towel or the cool rag instead of with his bare
Yeah.
hand.
It doesn't feel good. I've done it before. And the solder, that will burn you. I was actually going to put my safety glasses on. I forgot to do that because safety first. This stuff you don't want to get, obviously, in your eyes or anywhere. I've got some scars where the solder has dripped on me, and that it'll burn you, and it burns into you for a while. So, all right, I think that's cool enough. So we'll go over here. This is the PEX. This is the PEX tubing I was talking about. It's a lot more flexible, obviously, than copper. Of course, replace it, but this is just a little ring. There's different systems. Put this stuff on. PEX system.
Brianne, I think we've lost the audio for Neil there.
Okay. How about now? You hear us now? Bruce?
Yes, that works.
Okay.
Yep. Yeah, I can hear you now.
Okay, should we re-explain the putting the PEX fitting on there and how far up it should be, or did you guys hear that?
No, we didn't hear that. If you'd go back about 2 minutes, it'd be real good.
Okay.
So at the beginning of the PEX part, just start over there.
Yeah, so anyways, this is PEX tubing. It's a lot more flexible than copper. You know, as I said, you can only go so far with it where it'll get a kink in it. Now this piece is no good anymore. You'd have to cut this out or replace it with a new piece. It is a lot faster to put together than copper, like I said, so we use this in a lot of new construction. And this is the ring we put on. You want to make sure it's hitting both of these ribs. There's 2 ribs on this PEX fitting. So when you put this on, you don't want the ring to be all the way down to the fitting, and you don't want it too far away. You want to be no more than 1/8 to a 1/4 inch away from the edge of the pipe. My ring moved a little bit, so I'll have to move that. And just like that, that's all you do. And it creates a watertight seal. We actually have a gauge. I don't have it with me to check this. I should have brought it, but I don't know, you want me to go get it quick, or?
No, just tell them what it does.
There's a gauge that goes on here. It's just basically has 2 jaws, and there's one's a go side and one's a no-go side. So the go side is supposed to go all the way around this, just kind of slide on there nice and easy without binding or pinching. And then there's the no-go side, which if that goes on there, that means the crimp is actually too tight. So it's not supposed to go on there. So it just kind of tells you if you're within tolerance for your crimping tool, because these are adjustable. You know, if they get dropped or bumped, a lot of times you have to readjust them so that
You're losing your audio again.
Let me move closer. Okay, go ahead.
How about now?
Yep, good.
That's good.
Well, I don't know how much of that they heard or didn't hear, so we can
Pretty close to everything about you were talking about the go and no go, and I didn't hear completely all of that.
that's just it's a tool that checks this crimper basically to make sure this is within tolerance, so that it's not too loose or tight of a crimp is basically all it does. Okay, that's pretty much it for that one. This is our newest thing we've got. It's a Pro Press tool. This one goes all the way from 1/2 inch up to 2 inch fittings. And this makes life a lot easier. The fittings are quite a bit more expensive for this, but instead of soldering, it's just a lot faster. And this you can actually do while the water is still running. It's just this is the Pro Press fitting. It's a fitting with a rubber O-ring inside of it. I don't know if you can see that at all.
Yeah.
So it just slides on the end. Turn this guy. And when you do this, you obviously want to make sure that the copper is all the way inside the fitting, so it's bottomed out in there. But now that's done, and all there is to it. So I don't know. That's all I guess I've got set up. So we can probably go ahead and move on to the next one.
If you have a Pro Press fitting like you do there, can you solder another fitting later down the road, or will
Well,
that
not-
wreck the O-rings?
Yeah, you can't do it too close to it, because this can't get hot. You don't want to melt the O-ring in here. So usually, if it started with Pro Press, we don't go to soldering after that unless you want to be more than a foot away, I would say. Otherwise, yeah, you can ruin that O-ring in there.
Is that Pro Press the industry norm then, or is that what everyone's using? I mean, PEX is pretty much what everyone's using, but those are just more if you need to make a union somewhere or what?
Well, no, we do a lot of stuff in Pro Press too. The new or the remake of that CCM health building, we did that in Pro Press. A lot of places, commercial buildings have to be done in copper, so we would do this as opposed to trying to solder everything. If it's a new house, we'll use PEX most of the time. I like PEX a lot, but sometimes if it's out in an open space, it's tough to make that look good too, because it is so much more flexible. You get waves in it, and it just doesn't look quite as good. So there's certain instances.
What's your preference for everything, copper or PEX or those?
It kind of depends on what you're doing. I guess my preference is PEX because it is fast and it is a little more reasonable on price to do, I think, than these. Plus, the PEX is so much more flexible. You can, if you got a floor joist or something in the way, you can just kind of move up or around it. As to where copper, you can't do that. You got to offset with a 45 or a 90, and it ends up taking more time. But if it's in an open space, I like to see copper. I mean, I don't do it a lot, but it looks a lot better, I think, that way. Yeah.
Any other questions for Neil before we move on to HVAC?
Actually, I did. On the copper, some guys will use a wet rag all the time on those joints after they put them in. What's the purpose? I never do it.
It just helps cool it down.
Oh yeah.
If you're close to something that has like a softener that has the bypass, that has O-rings in it that can't get too hot, or a lot of times, if you just want to hurry it up, if you got to solder this together and then screw it into something, it's just quicker if you can. The faster you can cool it down is the faster you can work with it.
Okay.
Yeah, some people do it on every joint. I don't do that. I guess it's just basically when I'm trying to speed up the process of what it would take to move to the next point. So.
Okay.
Yeah.
Anything else? Okay, we're gonna move the ladder and things out of here, and then we'll go on to HVAC. I'm gonna mute you for just 1 second here.
Okay, we're gonna go on to a little bit of information about furnaces and heating, ventilation, and air conditioning. This particular furnace is one we've pulled out of a place, and we're just using it for demonstration right now. It's a Goodman 92%. This furnace is probably 25 years old or somewhere in that neighborhood. The reason we pulled this one out is because it has a cracked heat exchanger. We're going to go over some parts of this furnace, and I will show you some of the newer stuff in new parts and what this old furnace has in it. On the bottom of this furnace, we have the blower fan, which blows the air around the house. The actual filter sits over on the side of the furnace, and it draws the air in from the side, blows it up through the furnace. The fire comes on, heats up the heat exchanger. Let's come up and take a look at the heat exchanger.
You're losing your audio again.
Okay,
Newer furnaces almost always have like a muffler pipe tubing across the top. And once you come through the primary heat exchanger, you take some heat off of the furnace. Then it goes down into a secondary heat exchanger, which is similar to a radiator in a car or something like that. The gases are going through that secondary, and in the secondary, the gases are cooled to the point where condensation takes place, and so you get moisture coming out of the furnace from firing. The moisture has to go someplace, and so we have a trap built into the side of this one, which the moisture collects in there. The trap is to keep the exhaust fumes from getting into the interior of the house from the combustion. Back on the bottom, we have the furnace control board. We have a transformer here, a capacitor for the motor. We have the door switch, which is a safety switch, so when you take the door off, you can go in there without getting electrocuted. We have an exhaust blower or inducer, which actually sucks the fumes, the fire through the furnace, and blows the exhaust out to the outside of the house. We have here a pressure switch, which is actually a negative pressure switch. It's a vacuum. It's a safety feature to make sure that the exhaust blower is working before the furnace will fire. We have a gas valve or a gas regulator up here, which lets the gas on after it's got to the point in the firing sequence for that to happen. This one has a hot surface igniter, which is located behind the burners in one side of the burner pattern. On the other side of the burner pattern is a flame sensor, which is in this area. And as the fire starts, the fire has to cross from the igniter to the flame sensor, and the flame sensor will sense a small electrical charge through the fire. And if it doesn't sense it, it shuts the furnace back down. I have some parts here that might be a little easier to see for what we have for controls on the furnace. This particular control is a White Rogers unit. We also have, it's a universal, it fits many. I also have another universal here. And because there are so many different applications, we have different plugins to adapt this control to most furnaces. So there's a instructions with this control that will tell you which ones you need to use for which furnace. This is the gas regulator. This particular one is for a pilot spark ignition. That means that it has a pilot that lights instead of a flame igniter. The Honeywell, this is probably on more of an older furnace, possibly even older than this one. This is what the flame sensor, one flame sensor would look like. And it sits up in there. If this gets dirty from products of combustion, it will not sense the flame, and that's one of the most common issues that will shut a furnace down. So some of the time you can take this out and just clean it with steel wool or paper, something not real abrasive, and put it back in, and then the furnace will take off again. This is a different type of a pressure switch, and it's actually a negative pressure. It shows on there negative 1.7, which is measured in inches of water column. So to activate this switch, it takes less vacuum than you would have to suck pop out of a straw. That's how sensitive these are. So if you're taking the tubes off and blowing on them or sucking on them, you could very possibly damage this delicate vacuum switch. This is a form of igniter. This is a newer style, and it is I believe this is a silicon nitride, which is not as fragile as what older furnaces had in them. So this is what a new style Goodman furnace would have in it. This is a transformer. This particular transformer could be replacing the one that's in the furnace. It's a universal, and this one will work for 120 volts, 208 volts, or 230 volts. We should probably go through the sequence of operation on a furnace. The first thing that happens when you turn the power on is you get power into the furnace.
You lost your volume again.
Getting too far away again.
The,
Let's focus on the
the first thing that happens when you get the power turned on is the transformer is powered up, which will power your control board. The control board, most of them have a light on that will come on when you have power to the control board. The control board receives its signal from the thermostat to start the furnace. So we have 24 volts coming up to the thermostat and then coming back down to start the furnace. When that happens, The control board will check to make sure that the pressure switch is open. It's a normally open pressure switch. If it isn't open, it will stop the sequence and give you a fault code. If it is open, it will go on to the next thing, which will start the exhaust blower on the furnace. Once the exhaust blower has ramped up, it will create the vacuum that closes this pressure switch, and that will feed back to the control board to energize the igniter. The igniter will come on and glow for a predetermined amount of time that the control board has. After it has glowed for what it thinks is long enough to get a hot surface, it will energize the gas valve and let the gas come through the furnace. When that energizes, it will send the gas to the burners. The fire will start. If the fire crosses all of the burners to the flame sensor then sends the signal down, says the fire is on, let's keep it running. And then the control board will continue to keep the fire on. It starts a timer on this one so that after a predetermined time, probably 30, 60, or 90 seconds, the fan will come on to blow the air around the room. And that's pretty much what goes on when the furnace, if the furnace gets too hot, there are safety features involved. This switch here is the plenum limit switch. The plenum limit switch will shut the fire off if it gets too hot in the plenum. And then some control boards will let it restart again when the switch closes. Some will give a fault code and leave the blower fan running and the furnace not firing.
Okay, Rick, I'm gonna pause you there. I got a couple guys I gotta answer questions quick. I'll be right back. Okay, sorry about that. I had to answer a couple questions quick, but now we're back.
Okay, and that's pretty much the sequence of how things work on a furnace. Like I say, we use a lot of universal parts when we're fixing them. It just means that you have a lot less inventory to carry. Not every furnace will accept every universal part, so sometimes you have to go back and get the correct one. That's about it for this part. I'd like to show you one of our new furnaces and the difference in that, the heat exchanger, what the new tubes look like. So let's go back over to the heat exchanger on the new furnace. this one.
Hey, you need to step back about a minute and a half. You lost your audio again.
Over with the new furnace here.
Okay, this is the new style furnace with the muffler type tubing. The secondary heat exchanger is below that, the radiator type, where the moisture comes out of the exhaust. We'll open up the front on this one. Everything's much more compact. The reason for that is in order to make the new air conditioning coils fit in the space that we had in most basements, they made this shorter, but the air conditioning coil got taller. So that was one of the main reasons for shortening these furnaces up. This particular one has 2 pressure switches, checking both that the exhaust is not plugged or the intake is not plugged. Control board is down here. This particular furnace has an ECM motor for blowing the air around. I'm going to grab a couple of motors. This is what the newer ECM or electronically commuted motors look like. What they're doing with this, it's an energy saving motor. The actual motor will be running in DC current. It converts it from AC to DC in this capacitor module. This motor will use a little more power than what a regular light bulb probably. This is the old PSC motor. The PSC motor has to have a capacitor. This is a universal one. We can change the direction of the motor, reverse the direction of the motor by switching these 2 leads. It makes it so we can use the same motor on many different furnaces. This one has a 4-speed, so these wires go directly to the control board, and these would go onto a capacitor. I don't know. That's about all I have for right now. Are there any questions?
Can you talk about the efficiency of furnaces? Years ago, they were in the 80s, right? And now they're 90 plus.
Yes, the 80% furnace would be this, basically this furnace with just the muffler type tubing and not the heat exchanger that sits underneath of it. So 80% furnace has to be vented out with some type of a metal exhaust vent. It can be single wall out of the furnace, but whenever it goes through a conditioned space or enclosed space, it would have to be a double wall metal exhaust. These all have are the exhaust temperature on an 80% furnace usually is going to come out at least 275 degrees Fahrenheit. On the efficient 90 plus furnaces, it's going to come out between 90 and 105. You get much over 105, you've got some efficiency problems you need to fix. Either your filter is plugged or you don't have enough air going across it to keep that exhaust down. This particular furnace is a 96%. The newer or modulating furnaces will go 98% efficient. This old one over here is probably just getting 90%. It's called a dependable 92. Yeah, it might have got 92%. And that efficiency is how much it's actually converting the fuel that's going in and the electricity that it's using to run it and turning it into heat. Any other questions? Or did I answer your question?
Yeah, that was good. I appreciate it. And when you talk about, what did you say about modulator or modules?
Okay, modulating furnace is designed so that the fire can be regulated to reduce the BTUs. If you can have a lower BTU fire, you can gain more exchange of the heat off of your heat exchangers. So a modulating furnace will have a gas valve that will start the unit, and a lot of times at mid to high fire. Then it will slow down the amount of gas going in, and it will also slow down the exhaust blower that's blowing the exhaust out to match the combustion to get the best combustion with the right amount of air. It will probably, in most cases, go down to 20 to 25% of the capacity of the furnace. It will run at that rate for a predetermined time that's put into the control board. In most cases, probably 8 to 10 minutes. If it hasn't satisfied the call for heat, then it will start to increase the gas flow and increase the speed of the exhaust blower. It also will change the speed of the fan blowing the air across the coil, or the circulating fan. If it hasn't satisfied the call for heat in the, again, predetermined time, it will go to high fire and stay at the high fire until it's satisfied the thermostat's call for heat. Some furnaces will remember how long that took, and if it took a complete full fire, the next time it might not ramp down to the 20%. It might start at the 40% and then go from there to, the whole purpose then is to create an even temperature throughout the house and not have it cool down, heat up, cool down. And also the modulating furnaces seem to be quieter than the single stage and two stage furnaces. Any questions again? Well, I think that's probably it. If anybody has any questions, they can certainly submit them or call us, and we can answer some. Thank you for allowing us at Olson Plumbing to be part of your class.
Hey, before you go, can you talk a little bit about how you got into the trade out of high school?
Okay. Actually, I didn't get into the trade right out of high school. I tried. I was a mechanic for a while, and went to farming. Got into financial trouble with farming when the farm economy went bad in the mid '80s, and was looking for places to go. Went to Park Rapids to see a friend of mine, and I stopped at the Wadena Tech to talk to them about the plumbing program. The reason I was doing the plumbing is because when I took my tests in high school, that was one of the things that was suggested that I would be good at because of the mechanical ability that I had. So the program that I went to was a self-paced program, so you could go through it as fast as you could finish the mods or parts of it, or if you didn't get something, you could take as long as you needed. It's an apprentice program, so you start as an apprentice registered with the state, an unlicensed registered plumber, and that time then gets added on to what you need to have before you can take your journeyman test for plumbing. The HVAC part of it was basically for me learned on the job. I do recommend a tech school program. Most of the employees that we have that are doing HVAC went through at least 1 year of HVAC school. The reason that I think it's important is because there are too many ways to make mistakes that cost everybody money, and you can learn a lot from your instructors, from learning about how fire, how important fire and air and the mixture has to be in order to get efficiency properly. Also, in the air conditioning side, they will be able to get certified with the certified for different refrigerations. That can be done outside of the classroom, but I think that the classroom is probably the best place to get that. Plumbing wise, the class is going to teach you many different piping systems. Neil showed you some of them here. There's also threaded pipe. There's other systems like fire sprinklers use a different system than what we do. There's a lot of room in the industry for all kinds of different people, different paths that you can go down. The wages you get, depending on where you are in your experience level. If you come out of the classroom, you're probably going to be $4 or $5 more per hour than somebody coming off the street and entering the market here. You want to get into the management part of it. That you're kind of unlimited, I think, in income if you can get to that level. I don't really want to say how much money I make, but if I were working 60 hours a week, I'd get about $65 an hour. I guess that's about it. As far as interviewing for a job, I want people to come in neat, not chewing gum or tobacco. probably have some questions to ask, even if they're about the job or if they're about the company. I want to see some interaction with people, and I want to see interest. I want to see somebody that shows me that there's interest in what your company is and what you want them to be doing. Anything else you'd like to have my insight on?
No, it was very informational today and I appreciate it.
Okay. Well, then I think
No,
we'll
we're very
sign off.
thankful.
Yep.
Yep. Thank you so much, and we'll have it online for you guys.
All right, Brianna, is there anything you want to add? Brianna does all of our bidding. And so she also has fixes furnaces and does plumbing. So she's a very well-rounded person. She has she has experience in project management. And so she's very valuable to us. Everybody in our company that our techs has to do a weekend and on a schedule, and they get paid extra for doing that. Her and myself are also included in that. So,
All right.
Thank you so much.